Hi everyone, today I am back. So, welcome back to my YouTube channel. And today I am up with the next question of the top 150 interview questions on lead code. So, it's rotate the array. We are given an integer array nums. We have to rotate the array to the right by k steps where k is non-negative. So, let's get started with the question. So, let's take this example and 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 discuss the intuition as well as the approach. So we are given a nums array 1 2 3 4 5 6 7 and k is equal to 3. 1 2 3 4 5 6 7 and k is equal to 3. So moving our array to right, what does it mean? By k steps, it means that suppose we are having this one in the array, we have to move it 3 steps further in this array as per the question, because we are given k is equal to 3. So what would be our output? It would be something like 5 6 7 5 6 7 1 2 3 and 4, right? So this would be our output array. So before moving on to this question, let me ask every one of you one more question. So suppose my k is equal to 7. So what would be my output array, provided we are given this nums? So after 7 rotations, what will I expect my output to be? It would be 1 2 3 4 5 6 7, as it is same as input, right? So let me ask you another question. So what would be my output when I do 8 rotations? So I think what we can do is, what is 8? It is equal to 7 plus 1. So it means that after 7 rotations we have the output same as nums, and what we have to determine in 8 is the rotation of the array, rotation after moving our elements by one place, right? So when we are given that after 8 rotations, what would be the output of our array? It would be 7 1 2 3 4 5 and 6, right? And so if I get some k like 20, what would be my output? It would be 7 plus 6, right? So it is something like, so 2 7 rotations, which will actually give my input equal to output, and the result of the array which we have after 6 rotations, right? This is what we mean when we have k is equal to 20. So in order to reduce our extra effort, right? So what we can see that whenever our array length, whenever our k is equal to the length of the array, or we can divide our k in such a way that it becomes that it can be divided as sum of the lengths of array. What we can simply do, we can simply apply our maths, which is k is equal to k percentage n, right? By using this formula, what we can actually achieve in this, our k will always be in this range of 1 to n, right? So in this case, what will happen is that, sorry, it's not 1 to n, it's 0 to n, okay? So it will always be lesser than n, right? And so at max, how many operations we can perform on our array is simply, we are not required to perform any operation, we are not required to do any rotation, or at max we can do n minus 1 rotations on our array. So it means our solution will always be bounded between, so our k will always be bounded between 0 to n, right? So that's what the intuition behind using this formula is, right? So let's move on how to rotate our array. So So what we have to do, we are given 1 2 3 4 5 6 7 as our input array, right? And we have to shift each and every element by 3 positions. So let's take an array temp, right? And this k will actually help us right now. Okay, so we have to shift, let me just 1 2 3 4 5 6 and 7, right? So what we have to do, we have to shift our 1 to 3 positions. 1 is initially here, so where will our 1 go? It will go 1 2 3, right? So our 1 will come over here. So we are done with 1. So what about the 2? It will come next to 1. It is also shifted 3 positions from its initial. So we are done with 2. What about 3? It will come after 2, which is also 3 positions later than its original. And what about 4? It will come at a position which is next to 3, and it is also 3 positions from its initial position, right? So I think we are done with this. Okay, so talking about 5 6 and 7, where will they go, right? Since the index of 5 is it has got a little bit untidy, so let me mark the indices as 0 1 2 3 4 5 and 6. So talking about the first index, what it is 0 plus 3, it is 1 plus 3, okay, it is 2 plus 3, and it is 3 plus 3. So till this point our indices are inbound, like, so it means that our indices are lying between 0 till n. Okay, so we are good enough with it. But what about when, so when we try to fix 5 at some position which is k positions to its initial, so what we will get, we are getting 7, and 7 is out of our range, right? So in order to achieve this index in our range, what we will simply do, we can simply just do its modulus with our size, right? So it is basically 7% is 7, which is equal to 0. So our 5 will come at the 0th position. Okay, so this is what we have done with this. It is 4 plus 3 percentage 7. Okay, so what about 6? It is coming over here, and it is 5 plus 3 percentage 7. And what about the 7? It's 6 plus 3 percentage 7. So similarly we can apply all of these calculations over here as well. No issues of doing this. See, if it's not ruining anything, it is also preventing in ruining, right? So I think we are good enough to know that why we are doing this modulus with the length of the array. Okay, so I think we have copied all our elements in the temporary array. As we know that we have to modify the input array as it is, we will simply copy whole of this array in nums, and this will be our answer, right? We are done with this and our solution, and we have happily solved our question, right? And in the interview we can say that my question is solved. So let's discuss the time complexity. So you will happily say that the time complexity is O of n as you have traversed the whole array, and space complexity is O of n as you are storing the results, storing this result. Basically you have stored all of this result in some temporary array, right? So we are using extra as the temporary array of size n. Fair enough. But your interviewer will not be happy with this O of n space. He will ask you, why don't you optimize it to O of 1 space, right? So let's move further to discuss this solution. So let me copy the array once again. and we are having k is equal to 3. So let us compare our input and output, both of them. 5, 6, 7, 1, 2, 3, 4. So as we can see from the output, we are having two things that we can see. First is this one. First portion is this, which comprises of last 3 elements of the array, and second is this, which comprises of first 4 elements of the array, right? So we are having, so basically what we can see from our output is that we can divide our array into 2 parts. First, which is comprising of 1, 2, 3, 4, and second, which is comprising of 5, 6, 7, right? So we can simply divide this array into 2 parts. So in order to achieve our output, what I can see, how to bring my element 7, 5, 6, 7, and 1, 2, 3, 4. So what we are actually doing in this case, in this scenario, what is happening is that we are basically shifting this part, which is 5, 6, 7, entire to the first position. We are shifting 5, 6, 7 to the first position in the array, so to the first 3 positions, and we are shifting this 1, 2, 3, 4 to the last 4 positions, right? So in order to bring this 5, 6, 7 to the first positions, what I can simply think of, I can try something like reversing the array. Okay, so let me just reverse the array. Okay, what I'll get after reversal, it's 7, 6, 5 and 4, 3, 2, 1, right? So let's observe another pattern, like talking about the first 3 elements. So I think I have got these halves and this half at its correct position. So by reversing whole of the array, so by reversing my array from 1 to n, I have brought my both of these parts at their correct places, right? So in order to achieve the output as something like this, 5, 6, 7, wait a minute, let me just do this, 5, 6, 7 and 1, 2, 3, 4. What I can simply do, I can simply rotate the first k elements, right, which will give me 5, 6, 7, and I can rotate the elements after my k elements till the end of the array. I will get my correct answer. So basically in this question, what we are doing, we are first reversing the whole array, and then we are reversing the first k elements, and then afterwards we are reversing the last elements from our kth element till end of the array, right? So this is the intuition, and this approach will actually work in O of 1 space. So the time complexity will remain O of n because we are traversing the whole array, while because our reverse function basically works in O of n time, and the space complexity is O of 1, as we are not using any extra space in this. We are simply modifying our given input array, that's it. So I think this approach is clear. So let's code it off. So in C++ we have an STL reverse function, so I'll be using that only. So for other languages you can write the reverse function, which I will mention right now. So I will first do it in C++, and then I will tell you the reverse function for the same. So let's run this code. And let's submit it. What is happening? Oh yeah, I forgot to mention. Okay, cool enough. So we have forgot to mention about the condition that we have discussed. Okay, int is equal to announce dot size, and if my k is already equal to 0 or k percentage n is equal to 0, I will simply return X. And otherwise I'll update my k to k percentage n. I think we forgot this condition, right? So we can do it right now. So I've got an accepted solution. So let's discuss the reverse function. If someone doesn't work in C++ and want to know how we can write the reverse function. So in reverse function, I think it's really basic, but yeah, still I'll be discussing this code with all of you. I'm having a start index, we are having an ending index. So what I will do, I will simply swap my elements from when the start is less than equal to end. I think this is a basic pseudocode which I'm referring right now. I will store my element in some temporary variable nums.start, and then I will place my variable nums.end is equal to nums. I can replace my start with nums.end, and then I can place my nums.end is equal to and then I will simply increment my start and decrement my end. So this is the reverse function which actually works in the STL library of the C++, right? So you can refer to this code if you are not working in C++, or if you're working in C++, that's fine. You can use the STL code. Okay. So I don't want to go in deep discussion of this code, as most of you have already solved in the preliminary days of programming this question, right? But still, if anyone wants to understand this code, I've just mentioned in the comments, I will make a video on this code on this question as well, right? So I hope guys you have liked the way I teach. Then please do subscribe and like my video and subscribe my channel, and do share it with your friends. And if you feel that I'm missing something, please do mention it in the comment section, right? And if you want to get connected with me on topics other than the DSA, like how to prepare for placements or you need any guidance, a short term or a long term type, you can get connected with me on platforms like TopMeet and Preplaced. Okay, the links are below in the description. Thanks for watching the video, and enjoy your day.